Hi everyone, I am J. Chandran J, Assistant Professor in Mechanical Department from Emmanuel Arasar JJ College of Engineering, Nattalam. Now I am teaching about the subject Metrology and Measurements. First of all, coming to the first unit, Basics of Metrology. These units include measurement, factors affecting measurement, errors in measurement, measurement uncertainty. These four important sections are included in this unit. Coming to the fundamentals of metrology and measurements. What is measurement? Measurement is the process of comparing an unknown quantity with a known fixed quantity of the same kind called a standard to express the result as a number and a unit. Therefore, measurement is equal to numerical value into unit. That is the formula to find out the measurement. That means, once again I tell, measurement is equal to numerical value into unit. Example, a shaft length of 25 mm means the length is 25 times the standard unit millimeter. That means mm millimeter. Coming to the need for measurement. First one is interchangeability of parts. Ensures components made independently fit and function together in assembly. The second one is verification of design. Confirms manufactured parts meet the dimensions and tolerances specified by the designer. The third one is quality control and inspection. Provides the objective basis for accepting or rejecting a manufactured component. The fourth one is research and development. Supports experimentation, process development and product improvement. The final one is trade and commerce. Guarantees fairness in transactions where goods are bought and sold by quantity. So, these are the important points in need for measurement. Why the measurement is needed in the day-to-day life as well as in the all sectors. Measurement is very much important due to its this kind of main important points like interchangeability of parts, verification of design, quality control and inspection, research and development, trade and commerce. In every part, the measurement is needed in all aspects. The measurement process are define the measurand. First one is define the measurand. Identify the exact quantity to be measured, that is length, angle, force, etc. First one is define the measurand. The second one is select the instrument. Choose an instrument with adequate range, resolution and accuracy. The third one is calibrate or calibration. Check the instrument against a traceable reference standard. A standard means of value is also known as a calibration or calibrate. The fourth one is perform measurement. Carry out the measurement under specified controlled conditions. The fifth one is record and analyze. The final one is the record and analyze. That means the log the reading, apply corrections and evaluate the result. For a practical or a experiment, we can analyze or record the data due to the experimental or tabulation values according to the measurand and the required instrument and the calibration and the required means of measurement. Also, we can find out the final value due to the certified data on that particular practical or experiment. So, the final one is record and analyze. That much very much important on this measurement process. Log the reading. That means all the values of reading we taken in the experimental process, we can take the reading on the basis of the experimental working principle or the methodology used in that particular experiment. So we can analyze by means of the equations and other means of data like that. So the record and analyze is the very much important final process in the measurement process. And for coming to the next Role of measurement in quality control. Verifies conformity, detects variation early, basics for acceptance, enables SPC, ensures interchangeability, builds traceability. So, first one is verifies conformity. Conforms parts meet specified dimensions and tolerances is the first one. The second one is identifies process dirt before defective parts accumulate. The third one is basis for acceptance. Provides objective grounds to accept or reject production batches. The fourth one is feeds data into statistical process, control charts and trend analysis. The fifth one is ensures interchangeability, keeps mass produced parts consistent and assembly ready. Builds traceability, links results to national and international standards for confidence. These are the role of measurement in quality control. Coming to the next section, generalized measurement system. I already told that in all aspects measurement is needed in the day-to-day life to obtain the accurate value on the basis of the measurement. So the first one is primary sensing element. Dictates the physical quantity and converts it into usable signal. That is, the example is a probe or transducer is the primary sensing element. Give us an example to know about more. So it is a simple example. Coming to the next step, variable conversion element converts the sensed signal into a more convenient form for processing. The third one is signal processing element, amplifies, filters or otherwise manipulates the signal for accuracy. The final one is data presentation element, displays or records the final result for the observer, dial, digital display, etc. So we take a video or we taking a capturing or recording a music. It amplifies into some form of input signals and give it to the output signal with respect to its form of digitalized means of softwares or other like that. So we can get the input and give the output on the basis of the required software to digitalize or amplifies the input signal to the output with good quality. That is the simple example for the generalized measurement system by the way of a simple example of recording the video or audio in our mobile phone or our microphone like etc. in our PC like that. The given output is digitalized and give it to output with quality. We can gather informations on quality basis. Every measuring instrument like a vernier caliper to a computer machining computer manufacturing machining process can be broken down into these four functional stages. The swipe framework. 5 practical sectors determine the accuracy and repeatability of any measurement. That means swipe. S means standard, W means workpiece, I means instrument, P means person, E means environment. That is the short form of swipe framework. These are the important practical factors, 5 important practical factors to determine the accuracy and repeatability of any measurement system. So standard is very much important for the workpiece. Workpiece is very much important due to the instrument we used. The instruments to handle the person, a skilled person is very much important. So also the environment is very much important to the person's health conditions and the particular environment is very much needed for the quality calibrated equipments and the recording and analyzing of the input and the required output to get. Each factor is examined on the following. So standard, first one is standard, that is reference for comparison. The standard is the non-quantity every measurement is compared against. Accuracy and stability also included in the standard. Must be highly accurate, stable over time and resistant to wear or damage. Traceability should be traceable through a calibration chain to national international standards. Source of error. Any Any inaccuracy or drift in the standard itself is transferred directly into every measurement. W means workpiece. Material properties, size, shape and finish, thermal effects, elastic deformation. These are the important properties included in the workpiece sector. So, material properties include elasticity, hardness, surface condition, influence how the part responds to contact. So, the material properties include the mechanical, thermal, morphological, every etc. like that. And the size, shape, finish includes geometric form and surface roughness affect where and how contact occurs. The thermal effects means the temperature differences or thermal conductivity cause expansion or contraction altering true dimensions. So the final one is elastic deformation, that is the mechanical property of, that means contact pressure from the instrument can momentarily distort a soft workpiece. Third one is instrument, design and construction, calibration status, wear and friction, resolution and least count. These are the important points included in the instrument to find out the accurate value of that particular means of product or a material. So the first one is design and construction. Build quality and mechanical designs at the inherent accuracy limit. Calibration status means the out of calibration instrument introduces a consistent hidden error. Wear and friction means mechanical wear, backlash and friction reduce repeatability over time. Resolution least count means the smallest readable increment limits the fitness of any reading. The fineness of any reading means the instrument resolution and least count of that particular instrument. So the person is a skilled and experienced person is needed. A trained observer selects the right technique and interprets the readings correctly. Parallax errors. Viewing a scale from an angle rather than perpendicular causes misreading. The third one is handling technique. Improper positioning or excessive contact force alters the result. Reading and recording means fatigue or carelessness can lead to transcription and estimation mistakes. The final one is environment, that the temperature, humidity and pressure, vibration and dust, lightning. These are the important points in the environment. So the standard reference condition is 20 degrees Celsius deviations cause thermal expansion errors. That means the temperature included that environment on the workplace. So the person or a skilled person need a good environment for the quality means of working. So humidity and pressure means reference humidity about 55% RH and 760 mmHg is assumed for precision work as an assumed value. So vibration and dust means external vibration and airborne particles disturb sensitive instruments and readings. For the lightning, poor or uneven illumination increases the chance of observational reading errors. So each workspace or workstation, the environment is very much important due to the actual input value and the output values we taken. Understanding measurement error, that means a formula to find out the error is equal to measured value minus true value. The very much important formula, error is equal to measured value minus true value. So the first one is no measurement is perfectly exact. Every reading carries some degree of uncertainty related to the true value. The true value is never exactly known. Only its best estimate can be obtained through careful repeated measurement. So the errors must be classified to be managed. Recognizing the type of error is the first step toward controlling or correcting it. The systematic errors include the errors that occur due to a fixed identifiable cause and follow a definite repeatable pattern. Instrumental errors caused by wear, faulty design or incorrect calibration of the measurement. Environmental errors means the result from consistent deviations in temperature, humidity or pressure. So the observational errors means errors from a fixed habit or bias in the observer's technique. That means parallax. Predictable and correctable. Because the cause is known, these errors can be calibrated out or corrected. These are the means of systematic errors. The random errors means errors caused by unpredictable unknown factors that vary in magnitude and sign from one reading to the next. Unknown causes, statistical behavior cannot be fully eliminated, minimized by averaging. These are the different points may be caused on the random errors. Next one is gross errors. Gross errors means that the large errors caused chiefly by human carelessness mistakes or improper use of instrument. That means misreading the scale, wrong recording, instrument misuse, easily detected and avoided, etc. are the gross errors taken by the human actually. Next one is control of errors. How to control these errors? That means regular calibration is needed, proper instrument selection, repeated readings, environmental control, skilled personnel, correction factors, etc. are very much needed. So the measurement uncertainty definition and terms means type A and type B. Statistical evaluation. That means evaluated by statistical analysis of a series repeated observations, expressed using the standard deviation of the mean, reduced by taking more repeated readings. Type B means non-statistical evaluation. Evaluated by means other than repeated observation based on calibration certificates, manufacturer data or past experience. Relies on scientific judgment and available reference information. So estimation of uncertainty means expanded uncertainty U is equal to K into UC. So the first one is identify sources, quantify standard uncertainties, combine and expand. These are the four important estimation of uncertainty. Accurate measurement, awareness of swipe factors. I already we understand and we study about swipe factors. Error control and uncertainty estimation together form the foundation of reliable engineering, metrology and quality control. Thank you.